Okay, I hope I'm audible to all students who are attending this practice lecture for statistical methods for economics course. In this particular practice lecture, we intend to start with practice problems based on theory of estimation and hypothesis testing. This is theory of estimation and hypothesis testing. I have done this module in theory in depth in my statistical methods for economics course. In this lecture, we are going to solve a few practical problems based on this concept. Okay, so before digging deeper into the practice problems, let me quickly revise with all students the concept of sampling distribution of mean, which I have covered in my lectures on estimation. Okay, so from my lectures, recall from my lectures on estimation theory. The sampling distribution of the mean. Sampling distribution of the mean. So I can write that if x1, x2, xn is a random sample with replacement of size n from a population with mean mu and variance sigma square, then expected value of x bar is going to be mu and variance of x bar is going to be sigma square by. This is when the sampling is done with replacement or if the population is very large, infinite population. So I can write this is the case when the sampling is done with replacement or from an infinite population, from an infinitely large population. But today in this lecture, I'm also going to make all students write a note, which you will not find in my theoretical lectures on estimation. So let us see today in this lecture what happens when sampling is done without replacement. So I can write if x1, x2, xn is a random sample. In the bracket, I can write without replacement. That means the observations are not getting replaced. Without replacement, so it's a random sample of size n from a finite population. Now, with the population is not infinite, it contains finite elements from a finite population of size capital N. So capital N denotes the size of the population, small n denotes the size of the sample. Then variance of x bar will be sigma square by n times capital N minus small n over capital N minus 1. And expected value of x bar is still mu. So expected value of x bar will always be mu because x bar is always an unbiased estimator. X bar, that is the sample mean, I can write is an unbiased estimator of the population mean mu. Of the population mean mu. Variance of x bar is sigma square over n times capital N minus small n over n minus 1, where capital N is the population size, small n is the sample size. So I hope all students have understood the sampling distribution of mean. When the sampling is done with replacement or from an infinite population, then this is the result. If the sampling is done without replacement from a finite population, then this is the result. Now let's look at some practice problems based on this particular concept. Okay, so let's look at some practice numericals. So let me write the first numerical for all students. So this is question number 1. A population has a mean. A population has a mean of 0.1 and standard deviation of 2.1. Find the probability that the mean of a random sample of size 900 will be negative. So let's quickly solve. I'm quickly writing what is given to us. Population has a mean of 0.1. So mu is 0.1. And the population standard deviation is 2.1. Find the probability that the mean of the random sample of size 900, the sample size is 900, will be negative. So I need to find what? I need to find the probability that the sample mean x bar is negative. The mean of the random sample is negative. Now, if I quickly standardize this, so consider probability of x bar less than 0. After standardizing, we all know the standardizing procedure. You subtract from x bar its mean and you divide by the standard deviation of x bar, which is sigma by root. Remember, this is the standard deviation of the population. Standard deviation of x bar is sigma by root. So this should be less than 0 minus mu over sigma by root n. Okay. So this is going to follow a normal distribution with mean 0 and variance 1 once we standardize. Okay. So x bar minus mu over sigma by root n is just z less than 0 minus how much is mu? 0.1 over sigma is 2.1 over square root of 900. Is going to be probability of z less than negative 0.1 over 2.1 by 30. So this will be probability of z less than, if I quickly use calculator, students are allowed to use a calculator by the way. So if I quickly calculate, this is z less than negative 0.1 over 2.1 divided over 30 comes out as 0.07, which will be probability of z less than 0.1 divided over 0.07 comes out as negative 1.43. So we need to find out what's the probability of z taking the value less than negative 1.43. Okay. So if I draw a diagram just to help students visualize how to find out z less than negative 1.43. So this is my z distribution. This is 0. And this is negative 1.43. I need to find this area. How do I find this area? It is phi of negative 1.43. That means everything to the left of minus 1.43. So if I come to the Z tables now, so minus 1.4 under 3. So let's come to that. So this is minus 1.4, 0, 1, 2, 3. So my answer is 0.0764. This is from the DEVOR tables, 0.076. This is my answer for this particular question. Okay, so I hope students have understood how we have solved it. We were given population mean, we were given the population standard deviation, we were given the sample size. Okay, we had to find the probability of X bar taking the value less than 0. I standardize on both sides by subtracting the mean and dividing by the standard deviation of X bar. I put in the values, I get probability of Z less than negative 1.43. From the table, it's everything to the left of negative 1.43, which is phi of minus 1.43, and phi of minus 1.43 is 0.0764. Let's look at question number 2. Okay, from a simple random sample, without replacement, of size 8, in which the observations are as follows. The observations are as follows: 46, 8, 38, 24, 35, 29, 36, 40. Okay. Drawn from, so these observations are drawn from the marks obtained by a class of 18 students. So the population size is 18. The sample size is small a, is 8. In the monthly test, so these are the marks drawn from the monthly test in mathematics out of 50 marks. The question asks us find the estimate of the total marks of the students. Find the estimate of the total marks of the students in the whole class and the standard error of your estimate. And the standard error of your estimate. Okay, so let's quickly solve this particular problem. We are given the sample size is small n. We are given that the population size capital N is 18. We are given the observation. So X takes the values 46, 8, 38, 24, 35, 29, 36, and 40. Okay, so to calculate the total marks, one thing I can first of all calculate is the sample mean. Because the sample mean, from the sample mean, I can also not only estimate the population mean, I can also estimate the total marks. I can not only estimate the average marks of these 18 students, but I can also estimate the total marks. In order to do that, first let me calculate the sample mean. Okay, so what is X bar? The sample mean is nothing but sum of all the sample values divided by the sample size. The sum of all the sample values, if I sum them up, use your calculator and sum them up. So 46 plus 8 plus 38 plus 24 plus 35 plus 29 plus 36 plus 40 over n is 8. Use your calculators and verify, guys. The answer for x bar is 32. So I got x bar as 32. Now, what is the estimate of the total mark? So I can write that the estimate of, this is the mean from the sample. If I multiply it by the population size, I get the total marks. The estimate of the total marks of the students in the whole class is n x bar. What is n? Capital N is taking the value 18 and x bar takes the value 32. So this is nx bar. So 18 multiplied by 32 is 576. That means this is the estimate of the total marks in a class of 18 students. Okay, so we have got nx bar. Now, let's calculate the variance of nx bar, because to calculate the standard error of our estimate, we also need to calculate the variance, because then we take the square root of that to get the standard error. Now, first of all, let's calculate the variance of nx bar. So let me write what I got first of all. I got my x bar as 32. Okay, so I'm erasing this part off. I hope students have understood till here how we have solved it. We had to find the estimate of the total marks. Remember, how do you get the total? You multiply the, so the total is nothing but the size, population size multiplied by the mean. The mean from the sample. From this sample, the mean I got was 32. If I multiply this by the population size, because the population contains 18 students, if I multiply 32 by 18, I get the estimate of the total marks of the students in the whole class, which is 576. So I've solved for the first part. This was the answer to part A. Okay, this is part A. Part B was the standard error, finding the standard error. So let's work that also. So if I erase this part off, to find the standard error, I first find the variance, because then I'll just take the square root of that. And I need to first find out the variance of nx bar. Variance of nx bar will be just n square times variance of x bar, using the rules of variance which I have covered up in my lectures on estimation. And what is variance of x bar? Variance of x bar is nothing but, it's going to be 1 over n minus 1 over capital N times the variance of the sample, S square. And S square, where S square is what? Where S square is summation xi minus x bar square over n minus. So first of all, let's find out xi minus x bar. So x minus x bar is 32. So let's quickly work this out. 46 minus 32, 14. 88 minus 32 minus 24. 38 minus 32, 6. 24 minus 32 minus 8. 35 minus 32, 3. 29 minus 32 minus 3. 36 minus 32, 4. 40 minus 32, 8. And then x minus 32 square. 14 square 196, 24 square 576, 6 square 36, 8 square 64, 3 square 9, 3 minus 3 square 9, 4 square 16, 8 square 64. If I take the sum of all these, it's 970. This is summation xi minus x bar square. So my S square is 970 over small n is how much? 8. 8 minus 1. Okay, so if I now work out what is going to be variance of nx bar, it's going to be n capital N square. Capital N square is what? capital N is 18. So 18 square times 1 over 8 minus 1 over 18 times S square is 970 over 8. 8 minus 1 is 7. I can write this as 970 over 7 because 8 minus 1 is 7. If you use your calculators, which you're allowed to use, variance of nx bar comes out as 3117.857. You can cross check it right now. Students attending this lecture can cross check using a calculator right now. This is variance of nx bar. So standard error. Standard error of nx bar will just be the positive square root of variance. The positive square root of variance is 55.8. So this is the final answer for this particular question. So first we figured out what's the total estimate. The total estimate was capital N multiplied by x bar. That gave us the total marks. And then the standard error is just square root of variance of nx bar. First I calculated variance of nx bar. Variance of nx bar is n square times variance of x bar. Variance of x bar is 1 over small n minus 1 over capital N times s square, where s square is the sample variance. This is how I calculate it. So from x, I calculate x minus x bar, then I do x minus x bar square, then I sum it up. I get 970 divided by n minus 1. Small n is 8, 8 minus 1 is 7. S square is 970 by 7. I just put everything in the formula. So 18 square times 1 over 8 minus 1 over 18 times 970 by 7, which gives me the answer as 3117.8571. This is the variance of nx bar. I take the square root of it. I get the standard error of nx. So I hope students have understood this. And then the last question I intend to do in this particular lecture for practice. Let's look at this problem. If a random sample of 10 numbers is drawn without replacement. So the moment you see without replacement, you will apply the formula we have done without replacement for sampling distribution of the mean. So if a random sample of 10 numbers is drawn without replacement from the set 1, 2, 3, dot, dot, dot till 100, first 100 natural numbers, find the variance of the sample mean. Find the variance of the sample mean. So quickly recall that when sampling is done without replacement, the variance of the sample mean is given by variance of x bar is equal to capital N minus small n over capital N minus 1 times sigma square by n. In the beginning of this lecture only, we have done this particular formula when the sampling is done without replacement. Now capital N is 100 because the population goes from 1 to 100. Random sample of 10 numbers is chosen. So small n is 10. What is sigma square? Sigma square is the population variance. Now students can recall the formula for population variance. It's summation x square, capital X square by n minus summation x by n whole square. How much is summation x? 1 plus 2 plus 3 plus dot 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 100. What's the sum of the first 100 natural numbers? Something we have done in high school math. It's n into n plus 1 by 2. We have 100 natural numbers, so 100 into 100 plus 1 by 2. So we get 100 into 101 by 2. 2 cancels with 100, making it 50. 101 into 50 is how much? 101 into 50 is, we can quickly verify this, that 101 times 50 is 5050. This is summation x. Summation x square will be what? 1 square plus 2 square plus 3 square plus dot 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 100 square. Again, the sum of the square of the first 100 natural numbers is what? Remember, it's n into n plus 1 into 2n plus 1 by 6. So it's going to be n into n plus 1 into 2n plus 1 by 6. N is 100 into 100 plus 1 is 101 into 2 into 100 is 200, 201 by 6. If I calculate this, we have 100 into 101 into 201 divided by 6, which is 338, 350. So 100 into 101 into 201 divided by 6. I'm verifying it's 338,350. So this comes out as summation x square is 338,350 over 100 minus summation x is 5050 over n is 100 squared up. If you use your calculator now to find the answer, you will see that sigma square comes out as 9999 by 12. You can verify this using your calculator also. It comes out as 9999 over 12. Okay, so this is sigma square. So we have got everything. We have got sigma square, we know n, we know capital N, we know small n, just put everything in the answer now. So I'm writing that we have got sigma square as 9999 over 12. So I erase this whole part off. I erase this whole part off, and I'm just now going to put everything in the formula for variance of x bar. So variance of x bar is going to be 100 minus 10 over 100 minus 1 times 9999 over 12. So sigma square times 1 over 10. Again, use your calculators. You're allowed to do that and verify that the answer is 303 by 4. I've already solved it before, so I'm just writing a final answer. It's 303 by 4. Once you use your calculators, this is the answer you're going to get. So this is the variance of the sample x bar. So variance of x bar is 303 by 4. Okay, so I stop now in this particular lecture. The objective of this lecture was to quickly revise the sampling distribution of mean with replacement and without replacement, and look at some practice problems in this particular lecture. Now, in the next lecture, we are going to look at more practice problems. I'm going to look at more problems now on interval estimation. I can write practice problems on interval estimation. This is what I intend to look at in the next lecture. I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.